This video covers content from your Chapter 4, Section 4 lecture notes. We'll be taking what we've learned about systems of linear equations and applying them to a few different types of scenarios. Example 1 is a geometry type problem. The first thing we'll need to do for all of these examples is take the words in the problem and turn them into two linear equations. In example 1, we're given that the length of a rectangle is 5 inches more than 3 times its width. If the perimeter of the rectangle is 114 inches, find the dimensions of the rectangle. When we look at this first sentence, we're told that the length of the rectangle is 5 inches more than 3 times its width. Let's use L to represent the length of a rectangle. We're told that the length is, or equals, 5 inches more than 3 times the width. So whatever 3 times the width is, let's use W for width, we need 5 more than that. So now we have an equation that represents the idea that the length is 5 inches more than 3 times its width. Now let's take a look at the second sentence. In the second sentence, we have that the perimeter is 114 inches. Remember that the perimeter of a rectangle is equal to 2 times the width plus 2 times the length. So when we're told that the perimeter is 114 inches, we can write that 2W plus 2L is equal to 114. Now we have two linear equations with two variables. This is a system of two linear equations. To solve this system, we can use the substitution method or the addition method. Either one will work just fine and give us the same results. Since our first equation, though, is already solved for one of the variables, I'm going to use the substitution method. I already know that L is equal to 3W plus 5, and I could substitute that in for L in the second equation. Doing that, we have 2W plus 2 times 3W plus 5 equals 114. Simplifying, we have 2W plus 2 times 3W, or 6W, plus 2 times 5, or 10. Combining like terms, we have 2W plus 6W for 8W. Subtracting 10 from both sides, we have 8W equals 104. And dividing both sides by 8, we get W equals 13. So now we know the width is 13. To find the length, we can simply substitute what we just found for the width into this first equation. From that, we have L equals 3 times 13 plus 5. 3 times 13 is 39, and 39 plus 5 is 44. So now we know the dimensions of the rectangle are 13 inches by 44 inches. Let's go on to a different type of problem. In example 3, we have a problem involving interest. Jessica invested a total of $7,000 in 2 mutual funds. In the first year, the first fund increased in value by 6%, while the other fund increased by 14% in value in the same period. If Jessica made a total profit of $620 from these 2 funds, how much did she invest in the fund that made 14%? Let's start by talking about the information given to us in the first sentence. We have a total of $7,000 invested into 2 funds. And the rest of the paragraph is talking about how much she invested into each fund. That gives us a clue of how we should set up our variables. We have a certain amount that was put in one fund, and we have a certain amount that was put into another fund. Let's call those amounts X and Y. When we add those two amounts together, we should have $7,000 because she invested a total of $7,000. Already, we have one of our linear equations. Now let's write another equation that represents how much profit she made from these 2 funds. We are told that she made a total of $620 from the 2 funds. So however much money she made from each of the funds, she made a total of $620. The first fund increased in value by 6%. So if she invested X dollars, she made 6% on those dollars. In decimal form, that's 0.06 times X for the amount of money she made in the first account. The second fund increased by 14%. So if she put Y dollars into that account, she earned 14% of those Y dollars. In decimal form, We write that as 0.14 times y. 0.06 times x represents the interest earned in the first fund. 0.14y represents the interest earned in the second fund. And we know that she earned a total of $620. Now we have two linear equations with two unknowns. Let's start by getting rid of the decimals in the second equation by multiplying everything by 100. Multiplying each term by 100 will move the decimal place over 2 places. So 0.06 becomes 6, 0.14 becomes 14, and 620 becomes 62,000. So we have 6x plus 14y equals 62,000. Let's think about what we might want to do to our first equation so that we can easily use the addition method. We want to be able to add the two equations together and eliminate one of the variables. Let's multiply everything by -6 so that we have a -6x and a positive 6x. Multiplying this first equation by -6, we get -6x minus 6y equals -42,000. Now let's use the addition method and simply add these two equations together. We have -6x plus positive 6x, which equals 0, just the way we planned. We have -6y plus 14y, or positive 8y. We have -42,000 and positive 62,000 for a total of positive 20,000. Now we can solve for y. Dividing both sides by 8, we find that y is equal to $2,500. Let's revisit the question and see what we needed to find. The final question in this problem is how much did she invest in the fund that made 14%? Y was our variable that represented the amount of money that earned 14% in that second fund, and that's exactly the variable that we have found here. So the answer is that she put $2,500 into the fund that earned 14%. Notice that that means that she put $4,500 into the fund that made 6%. Let's go on to a third type of problem. In example 5, we have a mixture problem. Mixture problems show up in all different areas of life, from mixing chemical solutions to ingredients in a recipe and chlorine in a swimming pool. We need to be able to solve mixture problems. The easiest way to take on a mixture problem is to create a table, and I'll show you how to do that here. In example 5, we are given that Marie has one solution that is 40% acid and a second solution that is 20% acid. She wants to combine these solutions to make 250 milliliters of a solution that is 28% acid. How many milliliters of each original solution needs to be used? Hopefully this situation makes sense to you. She needs a 28% solution, but her only options are 40% and 20%. So she needs to figure out how much of each she should mix together to end up with the right amount with the right strength. First, let's list each solution that's involved here. The first solution is 40% acid. The second solution is 20% acid. And she wants a solution that's 28% acid. The real question is how much volume she needs of each solution. So let's make volume our second column. We don't know how much of the 40% acid she's going to need, so let's call that X. We also don't know how much of the 20% acid she's going to need, so we'll call that Y. But we do know that she wants to end up with 250 milliliters of the 28% solution. This column that we just labeled volume, we mean total volume for our solution. But let's get more specific. We need to figure out the volume of acid in a given volume of the solution. So we'll make that our third column. Let's start with the 28% solution here. Imagine that you have 250 milliliters of the 28% solution. That means that 28% of those 250 milliliters is acid. So how much of that is acid? 0.28 times 250, or 28% of the 250. That means we have 70 milliliters of acid in that 250 milliliters of the solution. Now let's work on our other two solutions. With our 40% solution, we have some volume X. 40% of that volume is acid. And we could represent that by writing 0.40 times x. Whatever volume x is, 40% of it is acid. And the same goes for the next solution. Whatever volume y is, 20% of it is acid. So we can multiply 0.20 times y to find out how much of that solution is acid. Now we have everything we need to set up two equations. First, looking at our second column, we know that however much of the 40% solution we have and however much of the 20% solution we have, we know that they need to add up to 250 milliliters. So our first equation is x plus y equals 250. Next, we'll look at our third column. 0.4 times x tells us how much acid is going to come from the 40% solution. 0.2 times y tells us how much acid we're going to get from the 20% solution. And we're going to end up with a total of 70 milliliters of acid in our resulting solution. So we can set up this equation as 0.4x plus 0.2y equals 70. And now we have two linear equations with two variables. Now that we have our two equations, let's see what we can do to solve this system. First, let's get rid of these decimal places by multiplying this second equation by 10. That will move the decimal place over one place on each value. This gives us 4x plus 2y equals 700. In order to be able to eliminate a variable, let's think about what we could multiply our first equation by. Let's multiply by -2. That way we'll have a -2y to simplify with the positive 2y in the other equation. Multiplying everything by -2, we have -2x minus 2y equals -500. Adding these two equations together, we have positive 2x plus 0 equals 200. This tells us that x must be 100. Knowing that x plus y must equal 250, this tells us that 100 plus y equals 250, or that y is 150. So now we know that Marie needs 100 milliliters of the 40% solution and 150 milliliters of the 20% solution. And we've successfully solved this mixture problem. And that will conclude this lesson on applications of systems of linear equations.